In this session, we're going to explain how to plot box plot, such as alpha diversity plot and beta diversity plot and species composition. In previous video, we already generated some files under the directory of alpha and beta. And under alpha directory, we created files such as alpha vegan text and OTO tab rear text. And to get the box plot, we need alpha vegan text and metadata text. You can see here that the row name is the sample name and the column name is the corresponding alpha indices, just like richness, chow1. And chow1 we will not use because it's give wrong error, ACE, Shannon, and Simpson. And in metadata text, you can see the sample ID and group. There are several methods to draw alpha diversity box plot, and the method one is to draw the box plot under command line mode, and the script is given here which we can run in the RStudio, and that the script detail is just like the parameters. You have to adjust all the parameter including index section, input file, experimental design, group column name, output directory, and image width, such as width 89 and height 59 mm. Then we can draw by running the script in R, we can get such kind of box plot. You can see here. You can see here that we get such kind of box plot. Different letter here, which you can see here, A, B, they are showing statistical significance among groups, and the horizontal bar within the box represent median. The top and bottom of the box represent the 75th and 25th percentile respectively. The upper and lower whisker extend to data no more than 1.5 times, and the interquile range from the upper and lower edge. And the method 2 is to draw the box plot is by using the diversity RMD file, which is already located in the EasyAmplicon result directory, which we downloaded from the GitHub. So what you're going to do, you have to copy that diversity RMD file in your own working directory. And after that, you can execute the code block from the beginning one by one. And then you can also use the right arrow to sequentially run each code block, or use NIT to run the entire document and generate web page report. So the result can be found in the alpha directory, specifically in alpha box plot richness PDF. And method 3 is to create box plot online by using the link given here. You can use this link, and now the 3 steps which I explained you, now we're going to practice them in RStudio. Let's start it. First, we come back in our RStudio. We will see here, this is now, so you can see here our analysis of linguistic diversity and species composition. This is your alpha diversity and the box plot of alpha diversity. Now we can see here that in which directory we are. We already in our working directory, EasyAmplicon. So what we will do, we just run this code. It's R script, DB script, alpha box plot RH. We will see here. And now in the result, we come here and we will see what we're going to do here. What we get here. Let's run this code. As you run this code, you can see now this is the next code, which parameter diversity index of richness chow1, Simpson, and Simpson is given. We will not prefer to use chow1 because of it giving error. chow1 index is wrong, so we don't use it. And then you can see the detail of all the parameters here in the script. So we will run this code. Now use loop to plot 6 commonly used indices. We can execute this code. And now we see here what we have. Now see here we generate just recently box plot richness PDF, and we will execute this code, and we can see here, you can see here what we are getting now: box plot chow1, box plot ACE, box plot Shannon, box plot Simpson, and so on. Then in order to draw alpha diversity histogram plus standard deviation, we will use this command. It's give us alpha bar plot richness PDF. So now let's go back to our folder and see one by one. This is alpha bar plot richness PDF with standard deviation. You can see here between over knockout group, over expression, and wild type group. And then we can Come back and see boxplot ACE PDF. You can see here. Chow one we will not use, as I told you earlier, because its index is wrong. We will not use it. You can just look at it. This is richness, Shannon, Inmixen. Now you get variety of box plot. It's depend on your data and what your aim behind run this analysis. So you can opt which one you can use and which is suitable to you for your studies. Now let's go back to the RStudio. Now we can perform dilution curve analysis as well. In dilution curve analysis, you can see here, rarefaction curve of richness shows that feature reach saturation stage with increasing sequencing depth. So now when we get this, when we run this code, we will see what we get. We obtained here alpha rarefaction curve PDF. Just have a look. This is alpha rarefaction curve, which shows us the saturation stage with increasing sequencing depth. Each vertical bar represents standard error here. You can see here. So let's see the next diversity Venn diagram. In order to compare the number of groups, such as 3 groups or 4 groups, you're gonna make comparison between them. Then you can just use Venn diagram, which is the best to see the comparison among groups. Execute this code. And in order to compare 4 sets, execute this code. Let's go back and we'll see here. You can see we just generated here Venn diagram of 3 groups and the 4 groups. We can see this is our 3 groups. See over here, it's our 4 groups, W, T, K, O, O, E, and all. Alternatively, there is another online link available through which you can plot Venn diagram, box plot, whatever you want. There is a list of analysis you can perform under that. Let's have a look at that online link. We can copy and paste the link here. So it's not okay. We will see here. So when you come here, you can see here box plot, you can see here bar plot, you can see here Venn diagram. Click over here Venn diagram. And when you come here, you can see there is demo data is available here, that how you can arrange your data to run this analysis and to get your desired visualization. You have to see the demo. And after that, after arranging your data, just copy the data and paste in this box. When you paste it, after that, you have to adjust some parameter according to your requirement. And then you will click here, plot, and in few seconds, you will just get the output. So here what you need your gene and you need your sample. And in our case, we can see here to create box plot online. This is for the box plot. Now we are creating box plot online. In order to create box plot, we can come over here. And then we will see here the method to create box plot by using this online link. What we're gonna do, that we have already metadata text and we have begin text file in our folders. So we have to copy the group column from the metadata text and the richness column from the begin text into adjacent column, and then copy and paste in the link. So let's have a look. Here we have begin text. You can see here we have to copy all and just open Excel sheet and paste over here. And then you need metadata text. For metadata text, we have to go back and copy all. In sheet 2 we will paste it. So according to the instruction, we need group from the metadata text, right? Copy this group and open another Excel sheet, paste over here. And for the begin text, you need to copy the column of richness and paste over here. Now copy this, paste over here. When you paste it, then you have to adjust parameters. As per instruction, select group for legend, choose richness for the y-axis. Let's group for the legend and y-axis for the richness. And then just click plot. Now you can see it will take just a moment and you will get the output. So similarly, you can use the Venn diagram like this and the bar plot, whatever you want. And for detail and for guidance, you can use demo data as well, but how you can arrange your data for each analysis. And then there is an alternative option to use these plots and Venn diagram by using RMD, diversity RMD file, which we already have in our EasyAmplicon result directory, which we downloaded from the GitHub. Let's have a look. The EasyAmplicon folder, which we downloaded from the GitHub, is with the name EasyAmplicon master. We can go to the result, and here, this is diversity RMD file. So what you're going to do, you have to copy this diversity RMD to your working directory. I just copy this. This is diversity RMD. So after that, what you have to do, you have to open this diversity RMD with your RStudio. Result. This is diversity RMD. Now you can see here. You can plot. Now see, you can use this diversity RMD to get principal coordinate analysis for Venn, upset, Sankey diagram, for rarefaction curve and standard error. You can get many visualization by running this diversity RMD file. It's given introduction. One by one, you can run this alpha diversity, rarefaction curve and standard error, beta diversity. So here we can see in detail that how you can use the diversity RMD file. You just, when you open this file in your working directory and open with RStudio, you just start running the code blocks from the beginning by executing them line by line and observing the variable on the right side. You can also use the right arrow to sequentially run each code block, or use knit to run the entire code like this. This is the knit. For example, you want to run this section, you just click over here, it will run all the section, and then you will execute all this section one by one, and you can run all together as one. The option is given here. So preferably the first is used the RStudio and the line commands, and after that you can use the diversity RMD file as well, and the alternatively you can use online server as well. It's depend on you which you want to use. You can use for your convenience. After that, we come back, and now it's beta diversity now. In beta diversity, you can see here that how you will create beta diversity is an ecological concept that specifically refers to the difference in species composition between different group or ecological niches. In the field of metagenomics, scatter plot are commonly used to display beta diversity between sample group. Common analysis method include principal coordinate analysis and principal component analysis and constraint canonical PCOA. While reading article, you often come across terms like PCA, PCOA, NMD, CPCOA, CCA, ARD, LDA. Essentially, they all form of ordination analysis. The process of for ordination involve rearranging sample in a visualization with low dimensional space, typically two-dimensional, to maximize the representation of relationship between sample in the scatter plot. Now we're going to run this, that what we will have when we execute the code against this. The first is distance matrix heat map. Now, taking break routers as an example, and this is the explanation of the parameter we're going to use in the script. Let's first come into the beta directory. We can see already we generated previously all the input, all the files which we're going to use in drawing the plot, and the tables are created here. Let's run this code. Now see, break routers feed map PDF. After that, add grouping nodes such as genotype and location for column 2 and 4. Execute this code. And then one by one. The distance matrix is similar to correlation, and we can try corplot and ggcorplot to plot more style, and alternatively we can use the online link to visualize this as well. Then primary coordinate analysis, the input file we use here beta PCOAR, and we need metadata text, and break router text we use as a input file, and the output will create break routers PCO PDF. So let's run this code. You can see here we just obtained break routers PCOA PDF. Now add sample label with parameter. Okay, before going to run this code, we will have a look here. The result being the beta, we will have a look here. Now see, we don't have here the group's name. Here we have the legends, but here we don't have. So let's see here, when we run this code, we will label with parameter. So this is without parameter here. If you're gonna see here, we don't have labels here, but in order to get labels here, we will continue to run this command. Okay, let's try. Come back, and now see, this is with PCOA label PDF. You can see here, now this is the labeling. You can see here KOWTOE. Now, the next is constraint principal coordinate analysis, CPCOA. In order to get the CPCOA, the script is given here, and in order to get the detail of each this plot, you will, when you will execute it, you will have a diagram against each. Now see, break root is CPCOA PDF here, and again to add labels, we will execute this code and have a look. CPCO label, and this is CPCO PDF. Now this is without the labels, and it's with labels. The next is species composition taxonomy. Under the species composition taxonomy, we're gonna draw stack bar chart, stack plot, and here we will take the phylum level as an example. The result will include two files: output sample PDF and output group PDF. We will execute this code and then modify color using ggplot manual. For this, we will now see stack plot paired. We will see here the output here. You can see here, stack plot group PDF here. You can see here the taxonomy. And then you have sample PDF. And then you will, one by one, you have a look to each. It's all about stack bar plot. Stack bar chart or stack plot. So in order to batch draw using input that include phylum, class, order, family, and genus, for total 5 level, we will execute this code. And we will see here under text. You can see here we get many PDFs here. You can see some C stack plot PDF. It's some C stack plot group PDF. It's some O stack plot sample PDF, group PDF, family stack plot sample PDFs, family stack plot group PDF, genus stack plot sample PDF, genus stack plot group PDF. So after executing all this, now come to the chart circular diagram using circleize. Taking class as an example, let's see here. The results are located in the current directory, circleize PDF. We can see here. We can come over here. Circleize PDF, we will see here. Under the raw, no. We will see here where the output is. Now see, it's circleize PDF and circleize legend PDF. Let's have a look here. You can see here. And then you can see circleize PDF. It's without legend. Now move and rename to match the classification level. We will execute this code. And then tree map realization, it's for reference. We will specify the number of features and image dimension to generate the tree map. We here top and 100, width 183 and height 180. We will execute this code. It takes some time. And we will see here that it will give us text map tree, and it's going to use OTU tab text, taxonomy result, and taxonomy text which generated previously. Let's have a look here. It's text map tree under the directory of text. We will come here and we can see. Now this is text tree. You can see here. Now in this section we learn how to use R to plot alpha diversity, beta diversity, and species composition by using the files we generated previously. In the next, we are going to use the differential analysis, and we will learn how to plot volcano plot, heat map, and Manhattan plot.